Hey everybody, how are you? Thank you so much for joining us, and I apologize that we're just running a little bit late. Turns out there's a squirrel running around in my room and I just lost track of everything over here. So I appreciate you guys jumping on with us. And this session is going to be about flammability. Don Gillis is going to condense the facts for us for about an hour or so. If you guys do have any questions that come up, just type them on into the questions box. We're going to address as many as we possibly can. And again, as always, we really appreciate you guys' time and your availability to jump on with us and help us just basically grow the knowledge base of the environment of the industry. So anyway, I'll turn it over to Don now. Don, kick it on off.
Thanks, Chris. I don't feel tardy. All right, gang. Sorry for the delay, as Chris said. We're going to have fun, fast 30 minutes and then an hour for questions, Q&A. Chris, if you want to advance the slide for me, please. So we're going to talk about mildly flammable refrigerants today. Of course, we're going to about the flammability. This was the first episode I believe we did, and we've had such an outpouring on flammability. We sent out options that you choose from, topics you'd like to hear from. So we're going to revisit this one. Obviously, things are going to be updated on some of the slides, and the questions are going to change. We are going to have questions, three poll questions throughout the presentation. And then we will also have a pizza giveaway at the end and show who won it last month. Go ahead and advance it if you would, Chris. So the first thing I want to talk about, the future of HFOs and HFO blends. Okay, that's the new kid on the block, the A2Ls, if you will. If you're not using ammonia, propane, CO2, you're going to be seeing HFOs and HFO blends, and a lot of them. So for the Chemours side, we're going to have the 454 series, ones A, B, and C. Now the B, we all know, is going to be what most OEMs have picked for their comfort cooling. The A and the C will be used for medium temp and also low temp applications. The A will be for charges less than 200, and the C will be charges over 200. Okay, the GWP lowers. Notice that the blends, all they do is we have R32 and 1234YF, and the blends just change the ratio if you look at the bottom of the screen. So it's really how I always say, how low do you want to go? It's how low you want that SST, that suction saturation temperature. Chris, you can advance the slide. So what is an HFO? Let's talk about that real quick before we get into the flammability. So what makes this different than an HFC? Go ahead and advance. So in HFO, we had CFCs, that would be like your R12. We had HCFCs, that would be your R22s. And then we had HFCs, which would be, I'm going to use the example as R410A. Now notice in the first two, the CFCs and the HCFCs, that first C is your chlorine, if you didn't know that. So notice that first C was removed in HFCs to try to deal with that ozone depletion, if you will. So we moved to the HFCs, and then we had some issues with you know, the emissions it was putting out, some heat and what have you. But when we talk about HFOs, quite honestly, gang, the HFO is nothing more than an HFC molecule in disguise. And what I mean by that, if you notice that, if you click it one time, Chris, if you notice those two carbon atoms next to each other, if you were to eliminate one of those, that's an HFC molecule. The point I'm trying to make here is the refrigerant's going to act, and just like it did before, there's not going to be a lot of difference. And if you've already been around OEM equipment manufacturers, you'll see there's not a big change there either. It's still going to act like a DX system. But what the engineers and chemists found out years ago, that if they put two carbon atoms next to each other, it breaks up much, much faster in the atmosphere. So advance the slide, Chris, if you would. So one more time, Chris. So we have the 134A molecule on the left-hand side, typically used in medium temperature, so like reach-in coolers for beer, pop, bologna, things like that. And then we have that HFO molecule I just showed you, 1234YF, which is used for air conditioning, and it's in a lot of the blends we already use today, and it's been in a lot of the blends we've used today for a very long time. What's great about it is it not only has capacity value, it also has a very low GWP. So if the EPA says this can only be this many GWP, it's a nice mixture to put in a blend to still get the capacity, but lower that GWP value. Notice at the bottom in the red box down below, You've got 134A stays in the atmosphere approximately 13 years, as opposed to 10 days with the 1234YF. The GWP value is night and day. For the 134A, 1430, and 1234YF is less than 4, which is great because even when you look at the lowest of the GWPs, we're talking about 1 and 3. So this being an HFO is pretty remarkable that they can come up with something this low, and that, as far as the GWP limit, something that's an HFO or an HFO blend for that matter. But this is strictly an HFO molecule. Advance to the next slide. So this is what I really try to connect this with the contractors or the technicians that are in the field when I'm training in the field in person, is notice our pressure temperature chart off to the left, pressure to the left, and the temperature at the bottom of the screen here. Notice the red and blue lines running almost parallel with one another. The blue is the 134A, used in automobile air conditioning, used in, again, medium temperature. And then 1234IF, that's basically taking over the industry as far as the automobile industry for a single component. As long as it's a smaller charge, 1234YF HFO molecule can be used by a standalone refrigerant. Advance the slide. We've got a poll question. Take it away. What two components make up 454 blends? Is it R32 34A? That should be 134A, by the way. R32 and R125, R32 and 1234IF, or none of the above. Pick which one you think it was or is. Are we seeing the polls come in, Corey?
Yeah, I'll hop in here. It looks like we have about 80% of people saying R1234YF. So that seems to be the correct answer.
Yes, that is correct. That is the correct answer. Very good. All right, very good, gang. Let's advance the slide. Are A2L refrigerants new to us? Are they new to us? Are they new to the world? Are they new to the US? They're fairly new to the US, but as far as globally, Asia and Europe have been using A2Ls for quite some time. They got away from 410A a lot sooner than we did. We're a little bit behind the rest of the world, to be brutally honest with you. So let's advance the slide and see what that looks like. Go ahead and pop through the next 5, advance 5 of them. So if you bought an automobile in the last, new automobile in the last 8 years, you have an A2L refrigerant on every car made, manufactured, and sold in the United States has 1234YF underneath the hood. Not only is it a smaller charge with less capacity or with more capacity, but it's just a win-win for the industry as a whole. Okay, 1234F, as you saw on your PT chart, very, very efficient refrigerant, smaller charge limits, and then a window unit, a PTEC unit, a dehumidifier, a mobile AC unit. All of these units for about the last 7, possibly 8 years have an A2L refrigerant. We just don't know about it. It's not on the national news or anything like that. But a lot of this stuff, like it or not, is Asian driven. And Daikin has some skin in the game with R32. So a lot of those things that you buy in big box stores, like the window units and stuff, those all come from the Asian driven market, if you will. We just don't make a lot of that stuff in the States. I remember not that long ago, if you're my age, we used to repair window units at the shop. We just don't do that anymore. It's kind of a throwaway product anymore because you can buy it so cheap at the big box stores. But I would challenge you to check out the next time you stay in a motel what your PTEC unit has refrigerant wise. So the takeaway from this is they're already around us. There's nothing to fear. They've been around us for some time. We just don't talk about it. Advance the slide, please. So let's talk about the classification process. It's done by a third party, first of all, so it's an unbiased opinion. It's a company, organization that tests a lot of things, and then it sends it to the proper organization. In this case, it's the American Society for Testing and Materials, or ASTM. They do all the testing, even though Chemours and our competitors and compressor manufacturers all have these testing labs. We want to make sure we don't have egg on our face, I guess, for lack of better definition. So they test it for us, and then they send those results to ASHRAE. Now, ASHRAE Standard 34 has to do with the toxicity and the flammability. And today we're going to be talking just about the flammability. Okay, so advance the slide. First and foremost, there is no propane in A2L refrigerants. Now, lock that away. That might be the next poll question. But in all seriousness, if you didn't know that, if you did know this, I can promise you a lot of the folks that are coming to the counters, that are out in the field, still are not aware of this. And we're going to kind of dive into why do they think that, and hopefully we'll shed some light on that. So I need everyone on the call to go tell 10 people there is no propane in A2L refrigerants. Next slide, please. So let's start out with one, Chris. Advance the slide. So up until not long ago in the United States, we had 3 classifications. We had one non-flammable, example would be 410A. Advance the slide. We had 2, example would be 152A, and this is considered flammable, by the way. And then we had 3, which would be like propane and butane, and this is highly flammable. Now we're going to come back to the new kid on the block, if you'd advance, to 2L. Now notice they didn't make it 1.5 or anything like that. They used a 2L. The reason I point this out to you and use this last is because this is so new that they had to make a completely new classification to classify the HFOs and the HFO blends as far as the 2L concerned. Now, the first letter that's omitted from this chart, A or B, is the toxicity. The 2L or the 2 or the 3 or the 1 has to do with the flammability. Again, 1 being non-flammable, 2L being mildly flammable or low flame propagation, and 2 being flammable, and 3 being highly flammable. And just so you know, if you were to draw an imaginary line between 2L and 2, the right of that line, 2 and 3, 2 on up to 3, would be the velocity, burning velocity is greater than 10 centimeters per second. Notice at the top of the box where it says 2. Down below on the left-hand side from 2L down, the burning velocity of the refrigerant is less than 10 centimeters per second. So for instance, in the case of 454B, R454B, it's like 5.2. And oh, by the way, if you're curious what that L stands for, this is what it stands for. It is the velocity of which at the flame front propagates or burns, the speed at which it burns, okay? Again, less than 10 centimeters or greater than 10 centimeters. In the case of 454B, it's 5.2. So let's advance the slide. So here's something you can go to AHRI's website. It's seen almost in everybody's presentation. Notice on the left-hand side of the screen, the increasing flammability. As the numbers go up, the flammability goes up. So we start with no flame propagation, and then we end up with higher flammability. Notice the lower flammability, A2L, that's the new kid on the block, and this is how new it is. If you take your B2, a classification, that was ammonia, and we've used ammonia since the turn of the century, so it's been around a long time. So this 2L classification is so new that when it came out, the ammonia folks looked at it and said, well, if that's a 2L, then we should be a 2L. Fun fact is ammonia, even though it's been used since the turn of the century, is now classified a B2L. Okay, so that's kind of a fun fact for you. Advance the slide, please. So let's take a look at what this looks like. They start out with a glass flask in our chambers up at Delaware at the Discovery Hub, but this is what they're looking at in all the chambers. This is how they test it. They add just enough air, just enough refrigerant. It's corked in this glass flask. They add it in. They've got a computer connected to that. They look for the perfect concentration, and then they hit some kind of ignition or electro or MIE. Okay, it's blended at this magnetic stirring device at the bottom, and they wait about 15 seconds for that blend to just get perfectly right, and then they hit it. Advance the slide. So this is what 410A looks like. And we say it's non-flammable, but as you can see, there's a flame there. But the trick here is the V, or the blue 90 degrees there. This is the template they've used for years with flammability testing. And as long as that flame stays inside that V as in Victor, or that blue 90, it's considered no flame. Okay. Now, if you advance the slide, if it breaks that line, it's then considered flammable. And then it's just a matter of how flammable it is. So when they tested A2Ls for the first time, this is what they saw. It just broke that template. Okay, that format that they use, that chemistry that they use, there's a formula they use that makes this V very important, the science behind it, how fast it travels. And you can see now that it's broke that line, so they can't move the goalpost, for lack of better words. They now have a flammable refrigerant on their hands. To give you an example what an A2 looks like, picture at that A2L picture, the flame being out to about the 9 and 3 positioning on the clock. Okay, so it's a big difference than an A2L. So therefore, they couldn't throw it in the A1 classification, and it was much less flame than it was for an A2. So therefore, this new classification, A2L. Advance the slide. This is why we as teachers get concerned when people classify a flammable refrigerant as a flammable refrigerant as a flammable refrigerant. They all don't fit in one bucket. This is propane, by the way. This is classified as an A3. You can see what propane does. And if you don't know, it's the same flammability as the propane we use in our gas grills, in our backyard, weekly, nightly, for get-togethers. We only need that little clicker, that little bit of spark to light it, unlike A2Ls. You know, I've converted over thousands of furnaces here in Ohio for heating, for furnaces, gas fossil fuel furnaces, and it's the same propane, which is highly flammable, obviously. The trick here is what a lot of people don't know unless you work with propane refrigerant is there's no stench to it. So in other words, there's no smell. So they add the smell so you know that this highly flammable gas is around you. But unfortunately, when you add that stench to the A3 as a refrigerant, it will not be, it can't be used as a refrigerant because there's too many impurities into it. So it's a whole different ball game when you walk into a mechanical room and you have a leak with a propane and you hit the light switch. That's night and day compared to a 2L. So that's why as instructors, as teachers, we really get concerned when people even talk about propane connected with A2L refrigerants. Advance the slide, please. So here's 410A. Here's an example of 410A. So if we didn't add refrigerant or propane to it, what did we do? So half of 410A, as you may or may not know, is R32, which is an A2L by itself, by the way. The other half is R125. Now, the two biggest things for my value on this is for R125 is it keeps the discharge line cool because, as you may know, R32 runs a little warmer, okay, than other refrigerants. It has a higher pressure, but the biggest one is it keeps it from being non-flammable. If you didn't know, R125 is found in a lot of fire extinguishers. So it's the fire extinguisher that makes it non-flammable. And the way R125 works is when it's exposed to air, it sucks the oxygen right out of it. Okay, without oxygen, we can't have a flame, right? So advance the slide, please. So here's what we did. It's a balancing act, if you will. Lower the GWP, raise the flammability. Most of the GWP value for 410A that the EPA didn't like was, in fact, the R125, the fire extinguisher. So we removed the fire extinguisher, we lower the GWP value to 466. What they did was, what Chemours did is they raised the R32, actually raised the A2L refrigerant up higher to 68.9 from 50, and then circled back around with that refrigerant that's underneath the hood of your car at 31.1%, 1234YF, HFO molecule owned by Chemours. Okay, so that's what they did. That is all that's in the 454B product right there. So they bumped up the 32, added the 1234F, getting the same almost exact capacity and a better COP, as we'll see down the road. Okay, the COP actually is raised, and the COP is nothing more than the capacity you're getting out of your evaporator compared to how much energy you're using on the compressor or the system as a whole. And 454 is much better than 410A and equal to R32. So advance the slide if you would, Chris. So here's some things we put together. This is some common things that we know that are flammable and what it takes to light. MIE is minimum ignition energy, the spark, that little clicker on our grill. It's done in millijoules. So the higher the number is, the less flammable it is, to point blank, put it quite simply. Methane is 0.47, propane 0.25. So that's really low and that's really flammable. When we look at 454B, we have about approximately 300. Gasoline 0.2, and then diesel fuel a little higher at 20. Okay, so advance the slide if you would, Chris. So here we're going to look at some household objects on the left-hand side. Advance if you would. These are the things that we are looking at. The cigarette insertion, does it light? A2L ignition, go ahead and advance. And you can go ahead and advance through all these, Chris, if you like. Barbecue lighters, plug receptacles, light switch, hand mixers, cordless drills, friction spark, hair dryers, toasters, hot plate insertions, space heaters insertions. None of this will light. All of these things have been tested not by Chemours, but by third parties. And there's not just one third party. There's been a lot of folks that's tested. I've seen many of videos out there where they have these items in the plexiglass box, if you will, adding just enough refrigerant, adding just enough of the air to be perfect to a light, and it just won't do it. And you'll notice that with the tools that are coming out too. A lot of the tools that are classified or rated or A2L compliant, some of those haven't even changed. Some of them have, but some of them have not. And I've yet to have anyone come back and say, hey, that tool that you're using now is not A2L compliant. Check me if I'm wrong, and please send an email if you find something. But I have yet to see anything, and I've worked with we all have worked with quite a few of the tool manufacturers. So let's advance the slide. Hey, it's time for a poll question. What is the poll question? So what's the MIE for 454B, the minimum ignition energy that you need to light 454B? Is it approximately 25? Is it approximately 230? Is it approximately 30? Or is it approximately 0.25? We're missing a decimal on that last one. So 25, 230, 300, or 0.25.
Looks like we have the votes rolling in, and about 85% of people are saying option C, about 300.
Perfect. Excellent. Good job. All right. Congratulations, everyone that got that right. Now, I'm not sure, we can try to play this video to see if it comes through. Obviously, you know, we had some technical difficulties. My computer was having some difficulties. I was going to play this through the computer with audio, but it may not play, Chris, the way we're set up now. So if we would just want to advance the slide, we'll go past this. Advance the slide. We're going to look at these one by one. The flammability limit, LFL or UFL, without it has to hit at least LFL for it to be flammable. So for example, a lot of the sensors that are in the OEM's equipment, no matter what brand you use, the UL required it to be no greater than 25% LFL. So no greater than 25% FL means that it's not even close to being flammable. Until it hits LFL, it's not flammable. It has to be in this window of lower and upper flame limit, okay? Minimum ignition energy is what we just talked about. What does it take to light it? Does it take a torch? Does it take walking across the carpet and touching a doorknob, for the instance like propane, like that little clicker we do on our gas grill? And then third, burning velocity, or SU, the speed at which a flame front propagates spread relative to the unburned gas. A fancy way of saying how fast it spread. And by the way, this is the definition of the L, if you don't know. Okay, I see a lot of people, low flame propagation, mildly flammable, but this is the significance of the L. It's the speed at which it travels. And then lastly, the heat of combustion. One more time, Chris. And the amount of energy that is released when burning a given amount of substance. And make no mistake about it, as you saw in that slide or that picture of 410A inside that V or that 90-degree testing, any refrigerant out there, if you add enough heat to a warehouse full of R22 or 410A or anything in your truck, it will combust. So I'm sure everyone knows that, but I want to be very clear that that's not something new to us, okay? So advance the slide. So here's a look at the ASHRAE safety groups. On the left-hand side, we have A2L. We're going to use 454B as the example. On the right-hand side, since this is the big hubbub that there's propane in it, we're going to compare it to what propane looks like. So the lower flame limit for the 454B is 297. For propane, it's 38. Notice the right side in the red arrows. The higher that is, the less the risk. Moving down to minimum ignition energy, or MIE, done in millijoules, it's 100 to 300, depending on how much charge. And then on the propane, it's 0.25, which is highly flammable, obviously. Burning velocity, again, the L in A2L, it's done by centimeters per second, and it's 5.2 for 454B. It's 46 for propane. Remember when I showed you that slide, or we showed you that slide earlier, we said on the right side of the line, on the left side of the line, we said it's greater than 10 centimeters per second. Well, you can see in the case of the highly flammable propane, it's not even close to 10 centimeters per second. It's way beyond it. Just like 454B is half of the 10 centimeters to be classified as lower flammability, okay? And then heat combustion done in kilojoules, 10.1 for 454B and 46.3. The lower that number is, the lower the risk. Let's advance the slide. So here's just a cheesy little slide of what that looks like. You have your upper and lower flame limit. So the takeaway from this is it's a much smaller window for 454B than it is for propane. So in other words, very little concentration, a little bit of a leak of propane mixed with 90% air or whatever that ratio is, it will light. You need a lot more concentration of 454B in the air, pardon me, to light that, okay? So there's a much smaller window, okay? So again, going back to those sensors that are going to be in the new equipment placed inside near the evaporator there in the coil box or the air handler, those are going to go off less than 25. In fact, most OEMs, the maximum I've seen is 20%. Some are as low as 12%. So they're not even close to being flammable yet before they go off, which I think is a great thing. Think of that sensor, in all honesty, as I think about it, it's another safety switch. It's no different than your pressure switches, your limit switches, and all the things that we have already in our equipment we do today. If you weren't having leaks before at your coils, your evaporator coils, you're not going to have leaks now. It's just a safety net for peace of mind, if you will, and it's going to go off way lower than it even is flammable. So just something to think about. Advance the slide, please. Hey, we got a poll question. What's the poll question? Pencils ready. What acronym describes burning velocity? Is it LFL, MIE, SU, or HOC? A, B, or C? LFL, MIE, SU, or HOC? What acronym describes burning velocity, or that L, the speed at which it travels? This is a hard one. Maybe not if you work backwards.
All right, we have some votes rolling in. It's a little bit of a split decision here. We have 30% of people saying LFL, 15% saying MIE, and 54% saying SU. So we still have the majority saying SU.
And SU is the correct answer. I probably made that a little trickier. I literally just made these questions up this morning. So, you know, the LFL is your lower flame limit. So let's talk about that just a little bit so make sure we're all on the same page here. Can we go backwards, Chris? Right there is fine. So that LFL, again, that's that window where it has to hit that. Until it hits that LFL, it's not even flammable. So that's that window where it's not even flammable. MIE is what it takes. Think of a force. If you were to Google MIE or minimum ignition energy, you would see a strike, like a match, basically. How much energy does it take to light it? Is it a torch, or is it walking across carpet and touching the doorknob with that static electricity? What does it take to light that? How easy is it to light? And then the correct answer, SU, is the burning velocity, and that's the one for the L. That's the speed at which it travels. Heat of combustion, of course, is just HOC. So we can advance back where we were now, Chris. All right, we're showing our training page here. We are at the end of what we were talking about, useful resources. I go to option.com. It's actually option.com/training. Somehow I got the old slide in here, but we've got lots of things on there. We have actually the checkup with Dr. Chucks. You can sign up for our refrigerant news page quarterly, I believe it is. And click it one more time, Chris, if you would. We have tech support there. Bobby Dean, we're going to be doing another episode or an episode next month and talking about tech support and all the things you'll find on the web page, by the way. And there's our tech. You can go tech-to-tech@chemours.com. A great service there. They also have these videos now, the chill zone on there. And lots of directions, lots of things. The folks behind the scenes that do all the heavy lifting of this are doing a great job. So we got lots of good stuff going on there. We can advance the slide here, Chris. We have a pizza party poll. Chris,
Yeah.
You want to take it from here?
I do. And so if you guys are new here, we do each month we select a winner, a random off the attendee list to win a pizza party. And so as you can see on the screen, what we do is we coordinate with you. We send you over to your branch 3 pizzas, a bunch of soft drinks, a bag of swag or a box of swag like koozies, pens, all kinds of stuff, and even a polo shirt just for you for being our winner. And so each month we select a new person. And this month it's Michael Tipton over at Johnstone Supply. I think they're over in South Texas, but the one that we've selected is Michael Tipton out of our random name selector. So Michael, I'll get in touch with you after this session right now. I've got your email address, but yeah, that's our winner, Don.
Hey, I appreciate it, Chris, and I apologize to everybody listening out there. I actually had a new slide here, and with all the confusion this morning, we picked up the wrong presentation. It's real close to what we were going to deliver, but there was lots of little mistakes there that I caught with the points and the different things that were corrected, and I do apologize for that because I just put this all together this morning. So thanks for hanging in with us there. Advance the slide, Chris.
Yes, sir.
We have questions, question time. Hopefully we have time. 12:40 on the clock. Bring your questions.
Yeah, we can see them when you type them in. Right now, there's just a comment. Don, another great class. Thank you to you and your team. And I see that's from Mr. Carlson. I'm just trying to see more of the page. But great job, Don. Really, you always do a bang up job for everybody. We appreciate you.
I didn't feel bang up today, and I know we're all chucking behind the scenes. We're gonna have a good laugh after this one. There was a lot of chaos going on, gang. I was trying to sign in for a half hour before, and it was so I had to flip over to my personal computer. Anyways, Chris, thanks for driving this today. Anyone have any questions, anything at all that we didn't touch on? Also, you know, if you don't have questions, topics that we want to talk about, any future, throw some topics out there, give us some ideas of things that you're getting hit with at the counter or out in the field or with your customers or whatever that looks like. You know, give us some topics, and we're working that up the next 6 months to stay ahead of the thing. So, and obviously those questions are changing. We're getting settled in on some of the things that we've already, you know, were kind of confusing to us, like the propane thing. I think it's getting better on that one. So, so any questions in there?
We do actually. A bunch are coming in. If I can just throw the first one
Awesome.
over to you. It's from our friend Steve. He was wondering, I saw that spark friction was a no. Does that mean that spark-proof tools are no longer in play?
So
that's a good question.
Yeah, it's a great question. So it might have been a little confusing. Those are the things that they tested, Steve. Was it Steve, Chris?
It was, yep, Steve
Yeah,
Stiefel.
so Steve, so what that was, again, it was from a third party, and there was quite a few people that did this third party testing. I've seen many of organizations do it. What they did was let's for to give you a visual, let's say they put those products, a toaster, a cordless drill that we're using nowadays, not A2L compliant cordless drill, and they put them in, let's say, like a plexiglass a box, if you will. And just like the testing they do in the chambers up at Chemours and other places is they added just the right concentration, just the right air to hit LFL, if you will, and they turn those things on, and they did not ignite. They did not start a flame. That's what it's trying to tell you there. They did not ignite or spark or have enough MIE to light that refrigerant, if you will. Hopefully that answered your question.
All right, good deal. Steve, let us know if you still need some more information on that.
Yeah, please. If
you got it. The compliment did come from Mr. Dean Carlson. Just wanted to make sure that that one got through. Mr. Michael, I'm going to say Shoop, was asking, why are sensors necessary when the requirement to hit LFL is so great? Why do we have the sensors?
Yeah, it's a great question. This got just brought up to me not long ago. I don't typically get that one. No one's ever questioned it, but the best way I would explain it to, and this is going to be it from a consumer's point of view, everything you see moving forward, a lot of this burden has been put on the folks that make the tanks, the folks that make the equipment, the folks that write the manuals. So ASHRAE is the safety of how we install it. As a contractor, that's what I had to follow under the IMC. UL is the safety of the equipment. So UL decides what they feel has to be a minimum, okay, that 25% detection. But the easy answer for that, and I'm not trying to sidestep the question, is liability. A lot of these companies, as we all know, they're billion-dollar companies. So like anything else with stickers that says, don't put this, gasoline nozzle in your mouth or you could die, things like that. We have to, it's just the world we live in now, unfortunately. So there's a detector there. It goes off if something should happen. They decided that blower should be activated after it does sense that. And then it lessens the concentration, which by the way isn't even close to the LFL already. So the fact that we're dealing with something different, even though it's fairly close to what we're using already, especially as a refrigerant, because of the different classification A2L, the UL decided, the equipment manufacturers, this is a minimum requirement that you have to have this sensor in there. With most equipment, residential wise, this is all you're going to see. When you get into the commercial, it gets into a little trickier where they're going to isolate part of the charge if they see a leak and then do a pump down and bring the refrigerant out there. So it's really about liability. Just like the refrigerant tanks, we went from a ruptured disc to a spring-loaded relief valve, if you will. Instead of blowing the whole charge, they're going to burp it. None of that was required, by the way. But UL required this. They also required a sticker inside the evaporator, indoor evaporator, or on the air handler that shows you the square footage to pounds you're allowed to have in a certain area. And it's really simple to look at. So it's just a safety net, basically no different than your limit switches or your pressure switches, which is required by UL2, by the way. In fact, I remember the story of the safety switch for the door by chance. If you know the story about how the safety switch got there for a door on a furnace, it's pretty incredible. And unfortunately, an accident had to happen. So that's how that was developed, that safety switch. So it's just another safety switch that's just there for the consumer, for the user, for the end user, that UL felt that needed to be there.
Nice. That's a great answer. I appreciate that. We do have some more that are coming in. The next one that I see here is from Mr. Michael Gwinnen. He's asking, are there different authorizations required for transporting A2L refrigerants?
So that's a great question on transportation. Unfortunately, we have people on staff that are really strong in that. So as far as the placards and things like that, yes. When you get into big box trucks or semis, there is different classifications on that. And I don't know that number off the top of my head. I want to say, Chris, do you know by chance know that answer?
Well,
Um,
my best understanding on it is materials of trade rules still apply, right? So the Department of Transportation says materials of trade, you can carry like 440 pounds of a flammable refrigerant in your service truck. So that hasn't changed. That's been around for a long time. Now, when you exceed 440 pounds, that's when you need to start having placards. But essentially, from what I understand, is the Department of Transportation has had rules in place for flammable and non-flammable material forever. So nothing has changed with regards to transportation.
Yeah, well said. And Chris is a dead spot on for the service vehicles. Nothing's changing there. No ventilation. Tanks will be allowed to be laid on their side. 440 pounds maximum has always been in place, as Chris said. That hasn't changed. That's, to me, that's kind of a good sign. I mean, they
Yeah,
didn't go down to 400. They didn't go down to 350. They didn't go down to 300. And that's not 440 pounds of anything in one tank. That's separate tanks. That could be 440 pounds of acetylene, which is
yeah.
much more flammable than A2Ls. So they didn't change that. They didn't feel a need to do that. So to me, that's kind of a good sign, if you will. But when we move up to the big box trucks, that changes with placards and different things like that as far as hauling. I hate to quote what I think the number is as far as the tanks, so I'm going to stay away from that. But if you would like to get the answer to that exact amount of A2L tanks on a box truck or things like that, if you want to email us after this or contact us, we will gladly get that answer for you. I think I know
Yeah.
the answer, but I hate to misspeak with this being going on a YouTube channel down the road.
And another thing to keep in mind too is that a lot of people are asking about transporting cylinders of service gases. And then the
Yeah,
other conversation that they have is transporting equipment with A2L refrigerants in there. And that's where it does start to get a little, you start to see some differences, right? It's something along the lines of like 20, if the piece of equipment has more than 25 pounds in it, then there's a rule or regulation somewhere that came up. So there's definitely two different questions to ask. But if you're just talking about like cylinders, DOT's been in place for a long time.
yeah, well said.
Okay. Moving on. Our good friend, Mr. Bob Erbacher, asks, are locations going to have segregated, or are they going to have to segregate the A2L tanks, or can they keep them in a fireproof cabinet? Ooh, so we're talking about warehousing and storage.
Yeah, yeah. So here's what I know, and then I'll let Chris knock it out of the park. But in curious, you chime in if I misspeak this. So if you go to AHRI, put in the Google machine AHRI A2L storage, and the first thing that's going to pop up is this beautiful trifold. It's colored PDF you can print out, and it is the guideline of what moving forward all areas down to the local fire department will be using. It's just not in place yet, but that's the guideline. Some folks have already incorporated that in, but not everyone. So they're still working on that part of it. So what I know of that is, as far as the storage, let's say you were only allowed a certain amount of area for like flammable gases prior to, because A2Ls are not as flammable as, like, let's say acetylene and those kind of things, that square footage has actually gotten larger for classified for flammable refrigerants. Okay, so there's a bigger space for that now, as opposed to, because A2Ls, as they know, are going to be taken over. So they couldn't confine those, because after seeing what they look like compared to what we're already using, they actually broaden that up. But as far as stacking and storage and locked up cases and things like that, I don't honestly know how that works. It's a great question, because they do that with reclaim tanks in warehouses. They'll lock those up and what have you, or under padlock. But Chris, do you have any insight on that in the warehouse area or the storage area?
Well, I would say there's very limited amount of information I want to be recorded saying, but I will say that essentially what's going on is your fire marshal your local fire marshal, your local authority having jurisdiction, needs to be taking a look at this. And up until A2Ls have been a thing, right? It's been either flammable or non-flammable. And the flammable gases, you've only been allowed to have about like 300 pounds. Okay, but A2Ls have changed that, and they've been adopted into some local building codes. And then in other places, other states that maybe haven't adopted it yet, they are leaving it up to the local fire marshal. And so what's happening right now is the fire marshal is already engaged with your branch, and your fire marshal now needs to understand what's up with A2Ls. And the change has gone from in the ballpark of 300 pounds to about 10,000 pounds if you don't have a fire sprinkler. If you do have a fire sprinkler system, then it's even greater than that, right? So the fire marshals definitely have the ability to authorize where to put these things, but the change has been great from a flammable gas to an A2L, right? So there has been a change. Your fire marshal does either know about it or at least has the authority to make the changes. And we have lots of information and lots of tools that we can help your local fire marshal come to the conclusions that he needs to in order to make those things. If you need some kind of authorization or something like that. I would say, here's the other part that I wasn't aware of, but essentially if your branch sells acetylene, your fire marshal knows about it and is already engaged in a conversation about your business having flammable gases, compressed flammable gases. So it's not strange to be having a conversation with a fire marshal. It's just a new conversation to have with them. That's it. And we can definitely help you.
Yeah, and that's a great point, Chris, what you just said, because I know for a fact, spending a small stint of my career, a couple of years as a territorial sales manager, that fire marshal comes into your facility quite, on a regular basis and checks, just like the food inspection people do. So here's what I do know, and I'll take it from the level that I speak at, who I mostly am in front of nationwide, and that's contractors and wholesalers. We already talked about the van. Nothing's changed there. 440 pounds maximum in individual tanks. When it comes to the contractor, as far as their facilities, I have not seen anything different than what you're already doing today with, let's say, 410A. The wholesalers, the same thing as far as stacking, all that things. And Chris touched on the square footage and what that looks like moving forward with A2Ls. So I have not heard of anything or seen of anything, and I'm sure in the last 2.5 years being here at Chemours, if something like that would have jumped out, even internally, we would know about it, I would think. So I have not seen any different compared to the storage from the A1s to A2Ls as far as contractors, their shops, and the wholesalers as far as the stacking restrictions. But please go to AHRI's A2L storage in the search bar, and you'll see exactly, and it'll spell it out for you. And again, one more time, as Chris said, at the end of the day, if you're not under codes, and a lot of people aren't, like I'm under the IMC, if you're out in the middle of nowhere and they don't have any codes, your local jurisdiction might be your volunteer fire department. They have the final say on what that looks like.
Yep, that's the way I was when I was growing up. That little volunteer fire department ran way more than you think they do.
Yeah.
Let's see. That's a really good conversation. And I've got another question on here from Jeff Craner, but it's kind of related. He's asking again, are there any limitations as to how much quantity A2Ls can be stored? And I think where you were guiding them to that AHRI page is where you would have that information.
Yeah. I don't know if we have a way to put that in a link or not, but if we have the emails, everyone, I think it sounds like it'd be a good idea to, in hindsight, I wish I would have incorporated. We probably should incorporate it on every one of the presentations. So you've brought a great idea. Actually, I think moving forward, we'll have that up at the end of every presentation to let you know about the storage, because it sounds to me like it sounds like what I'm hearing, Chris, is this is an episode.
Yeah. Absolutely.
So, yeah.
Well, that's what we've got for the questions so far. And Marissa Minicello, she left a comment, and maybe she can tell us a little bit more. But she says her comment is new hire Chemours basic info for onboarding. And I don't know if she's asking, is there like a basic info pack that we here at Chemours are exposed to, or anything like that, any kind of collection of information. I'm not really sure what she's asking exactly, but there's going to be a lot of sources. And Don, this is probably along the same lines as what you were just talking about. It'd be nice for us to put together a little like basic info pack. Here's where you go to get this information or that information, you know, that kind of thing. But you know what? Also, maybe talk about those Dr. Chuck videos. He does a fantastic job of explaining all kinds of stuff.
I think you're exactly right, Chris. I think what generated in my head is going back to the website, and actually that's our next presentation next month for March. We're going to be talking about tech support, and we're going to be working in our training page. And on the training page, if you go there, to Chris's point is, if you scroll down, you'll see all the resources that we give you to touch on their training efforts and what have you, whether it be ESCO, ACA, RSES, and all our partners, if you will. So there's a lot of resources out there, and I'm not just saying this because I work for Chemours, but the Opteon.com/training page is incredible right now. It really is. It's amazing to me how much they've done in a very short time. The goal is to make it the one stop, if you will, one-stop shop. And it's got a lot of things on there, including the Dr. Chuck videos, 4-minute videos, and you'll see all this in March. I believe it's the 4th, if I'm not mistaken, but you'll see all this moving forward next month. We're going to walk through that by page by page, or at least topics that we think would interest you. And that's going to be one of them. Where to get those resources at, data pages, and we'll throw in there, like your storage PDF also, and those kind of things. But I would start with that, if you would, because what I do know about the Opteon page, everything's free. We don't charge anything for that, which is really, really, I love it. And that's rare. You can go to the other places, and there's nothing wrong with charging for training, but you can actually go to our page and get connection links to other folks' pages on, like, what you called an onboarding thing, basics like that. And we have quite a few of these videos too, the webinars that are very simplified. When we first started, like this one in case, that look at the very basic fundamentals. I think we did one on tools, trucks, and tanks. We did one on installation, and they're very fundamental. They're very easy to digest. I mean, they're an hour long, but quite honestly, the presentations are probably 35, 40 minutes long, and then we take Q&A like we're doing now. So lots of good information. And again, if you want to help with that, you can reach out to us. I don't know if someone has the capability of putting in the chat area, what an email or a contact information. We can set you up with that. I'd be glad to help you out with that. I normally have my email at the end, but yeah, great question, and really, really, really want to help you. So please reach out. We'll get you all those resources. In fact, that might be another thing we'll add to the next presentation, and moving forward, maybe all the presentations of some resources we like. I show it in class. I just didn't do it on this presentation.
Well, good deal. Well, we are back at the top of the hour, Don. We made it. Guys, if you ever have any questions out in the audience, if you ever have any questions, send them to us in stuff like this, or reach out to us. If you go over to the website, there's places to contact us. We're gonna get your email, right? So please engage. We're happy to send you whatever we can. Let's see. And we do this every month. It's the first Tuesday of every month. And you never know when you're gonna win a pizza, right, Michael? So that's us for the day. If you guys have anything else, please reach out to us.
Thanks, everyone. Have a great day. Thanks, Chris.
Thanks, y'all. Bye-bye.